Every year, the animal farming industry slaughters tens of billions of animals for meat, causing immense suffering. What's more, the animal farming industry is one of the biggest contributors to global warming, producing a fifth of greenhouse gas emissions and using two-thirds of the world's land for livestock and animal feed. To make things worse, the Food and Agriculture Organization expects the demand for meat to almost double by 2050. So how can we meet this demand in a more ethical and sustainable way without compromising on food safety, quality, taste, and texture? Well, one way is through large-scale cultivated meat production. Cultivated meat is just real meat that is produced from stem cells in a lab. This is possible thanks to the multipotency of stem cells, meaning that they can expand and differentiate into different types of tissues such as muscle and fat, the main components of meat. To do this, a harmless biopsy is performed on an animal to harvest some of its stem cells. This is only done once, and the cells are then preserved in a cell bank where they can be kept and used forever. The cells are then grown and differentiated on 3D microcarriers in large tanks called bioreactors, and the resulting tissues are then combined to provide shape and texture to the final meat product. By controlling the entire process, scientists can guarantee a sterile environment without harming any animals. At this point, you might be thinking, if cultivated meat is so great, why have I never seen it in shops before? Well, firstly, it's a new product created for consumption, which needs complex regulation to legalize sale that few countries have yet to accept. Next is the low scalability of manufacturing cultivated meat, which makes the final product very, very expensive. My project aims to improve the scalability of cultivated meat production by designing an edible microcarrier that will significantly reduce production costs. My microcarriers are made of silk fibroin, a natural, abundant, and sustainable protein that is widely used in the tissue, engineering, and food industries. They are manufactured using electrospinning, a reliable, reproducible, and low-cost technology that generates structures resembling those found in muscle. After characterizing my microcarriers, my results have shown that they can support the growth of bovine stem cells, which are the focus of my project. Overall, these novel microcarriers have a potential to reduce industry dependency on plastics and expensive functionalization techniques currently used to generate large quantities of cells. They will also provide a more natural, sustainable, and low-cost environment for tissue development. Ultimately, my project could bring cultivated meat one step closer to your local supermarket while globally reducing animal suffering.